Hi, good evening, guys.
Morning, Kranti.
Hi, Kandi.
Hi, Raghuveer. Hi, Sid.
Hey.
Hi. Right. So in the last few classes, we have discussed about advanced mapping techniques. So we have seen how Tableau reads the data and then identifies the geographical data. We have seen how Tableau also recognizes the um, geographical roles depending upon the data that you give into the Tableau. So there's a built-in geocoding, so which automatically recognizes the data and then converts into a geographical role. So we have seen how we can modify different locations also. So the example that we have taken is um, that the distribution centers task. So here we have seen how we can assign regions to different states: California to West, um, East to Pennsylvania, so international to New York, South to Georgia. Okay, so and we have seen how we can modify the locations like this. Okay, so we have we'll see how we can. So we have also seen a dual axis map where it is a combination of both a field map and a point map, and we can also further divide the point into different subsegments using a pie chart for uh, using a dimension, for example a department here. Okay, so this is a combination chart or dual axis map. You can also call it as a combination chart or a dual axis map. Okay, so yesterday we have seen how we can blend two data sources, one data sources having a common field, one having this is a restaurant data. So in one data source we are having um, uh, website data and the URL data, and in other data source we were having the uh, name of the restaurant, which is a common field, and also um, um, and also the latitude and longitude values. So we have seen how we can combine those yeah, by taking one as a primary primary uh, s- primary field, which is restaurant name here. Okay, so we can plot it onto the view. So here we are able to see website from event log, and from location mapping we are able to plot the latitude and longitude. So these are the things we have discussed till now. And also apart from this, we have also seen how we can use the different options available in maps. So um, so we have tested few cases, test cases in maps. So we have seen how we can identify the textual fields if the geographical role is not automatically identified. We have seen how we can set the geo role manually using different test cases. And later on we have seen background maps. So we've seen offline, online. So in map there are different options. So offline map, online map is called as Tableau now. So we have seen how we can also in map services, how we can connect to WMS server, how we can connect to WMS servers, and also map box maps. Okay, so we've seen the procedure to add these two options in Tableau. So we have discussed with some tasks so to add this map box and also WMS server, which is a neo WMS server, which is a NASA Earth Observation server. So it's a freely available server. So we can connect to that, and then you can plot that in the back of the map. So we also seen how we can use custom territories and also how to find the radius on the map in the yesterday's class. So these were the topics that we have discussed on map. So there are a few more topics like custom geocoding and path path map mapping point to point, and also background images. So we'll cover these topics, and we'll be able to finish the uh, mapping topics if we cover these three topics. So first we'll look into custom geocoding. So our intention or main motive is to pl- plot a graph like this. Okay, so where uh, so our data is like this. So earlier our data will not be like this. So we will have only a data like this. So basically, what is custom geocoding? So if you want to plot the map for the field which is not having default geographical role, then we need to obtain latitude and longitude for that field manually, and this process is known as custom geocoding. So in the data that we have, so we have country, state, city, and address. Okay, so but we don't have the latitude and longitude. Okay, so in this data source we don't have latitude and longitude. So uh, what we will do, so we can procure the latitude and longitude, and then use that in our visualization. So we'll see how we can do that. Okay, so copy this text and search in Google as batch geocoding. Map develop. Okay, so you can um, look into any of the links that appear. So I'm using this map developers. So I'm pasting the same here and then clicking on find addresses. So it will automatically generate the latitude and longitude. The first column will be latitude, then the second column will be longitude. So um, what I will do is um, I'll go back to the um Excel again. Here what we have done is we have automatically generated latitude and longitude by clicking on um, find addresses. Okay, so by searching batch geocoding in Google. Okay, batch geocoding in Google. So we'll be getting few options like this. So you can use any of the options. So I'm using map developers. So what I'm doing is I'm just copy pasting the data that I've just have used in the Excel file. So and clicked on find addresses. So the latitude and longitude will be auto generated like this. So I'll go to the Excel and create two new columns with the names latitude and longitude. Okay, so I'll copy paste this data. So these are the coordinates for these two addresses. Okay, so now I will save this onto my desktop, and then I'll I'll connect to the I'll connect to the I'll connect to the workbook, and then I'll use this latitude and longitude in rows and columns. These are the latitude and longitude values that we have used just generated and then copy pasted into our Excel sheet. So here we are able to generate this. Just a second. 17, 12, 78, 77. 17, 12, 78, 77. Okay. Right. Right. So I'll drag drop these again. Um, I'll manually drag the latitude into rows and longitude into columns. Okay. So here um, I'll drag address and drop it into labels. Okay. Now in marks card, I will select line. So I'm able to generate the coordinates, then plot that on a graph like this. Okay. So I got the exact coordinates of Google Gachibowli Hyderabad, then Oracle Whitefield uh, Bangalore. Okay. So like this process is called as geocoding. This process is called as custom geocoding. So if you don't have coordinates of a field that you are looking out for, so you can generate the coordinates and then plot that in a graph like this. Okay, so it is showing the exact location. So Whitefield is on the north east part of Bangalore, and Google Gachibowli is in the western part of Hyderabad. So they are showing the correct coordinates. Right. So this is how we can use custom geocoding and then plot a graph like this. Okay. Right. This is one topic that I wanted to discuss, and there are also a couple of topics. Okay. So the next topic that we are going to discuss is point to point mapping. So path mapping of point to point distribution. So this type of a mapping is called as path mapping of point to point distribution. Point to point distribution. So here the path property. So whenever you are using this chart, so you'll have the extra shelf here called path. So you'll have a extra shelf here called path shelf. So when you're using this visualization, so this path property allows you to encode data by connecting marks using a particular drawing order. Okay, so if you are using any field into marks, so if it is a dimension, a particular order is followed, and you can define the order also. And if it's a measure also, it follows a particular order. We'll see how in what way the order is followed. So in the first place, what we have to remember that the path property allows you to encode data by connecting marks using a particular drawing order. So you can path encode your data using either a dimension or a measure. So you can use a dimension or a measure onto path, and then you can plot that onto the visualization. So if you are using a dimension, so path order. So path order is a measure here. Okay. So we are using a measure here into path. So if so we'll see what happens if you use a dimension, what happens if you use a measure. So because we are using a measure, we'll see what happens if you use a measure. When you place a measure on the path shelf like this. So path order is a measure, so which is appearing under measure. So and also continuous measure. So if you place the measure on the path shelf, Tableau connects the marks according to the values of the measure. So it is a continuous measure. So there will be continuous number of values in the measure, right? So it connects the so what are the measures here? So here if you see path order, so these are the values in it: 631 361. So these are the few of the values in path order. So if you use this path order in the visualization, how will they be represented? So a Tableau connects the marks according to the values of the measure. So it will sort in any of the order, and it will show that according to the numbers. So either 1 2 3 or 6, 1 2 3 4 5 6, or 6 6 5 4 3 2 1. So in any of the order, it will plot on the graph. So the measure can be aggregated or disaggregated. So the aggregation is not an issue here. So it can be an aggregate, or we can also disaggregate the measure and then show it on the view. Okay. If we use a dimension, so this is a measure. So if you use a dimension, when you place a dimension on the path shelf, so Tableau connects the marks according to the members in the dimension. So um, there will be members in a dimension, right? So for example, in segment, uh, so depart and return are members in the dimension. So uh, it is following a numeric order. So even Tableau will show according to the numeric order for dimensions. Okay. So Tableau connects the marks according to the members in the dimension. If the dimension is a date, so for example, if a dimension is a date, say order ID, so order date. So basically, it will have a continuous dates in it. Okay, it will have continuous dates in it. Okay, so if you see the data, view the data, you will be able to see continuous dates in a order date. Yeah. So like this, we'll have uh, a lot of dates in order date field. So if you use this dimension in path, so uh, the drawing order is given by the date order. So depending upon the date order, the drawing order will also be in the same order. Okay, right. So if the dimension holds words such as customer names or product types, the drawing order is given by the order of the members in the data source. So if it is a uh, say order priority, so it will be according to the members. So low, critical, not specified would be in certain order. So according to that order only, so that will be plotted on the graph. Okay, so you can change the order by which data points are connected. Okay, by changing the sort order of the members. So by you can change the sort order, and by changing the sort order, you can show the way they are shown. So for example, um, if it if this is region, so you can um, You can first plot that onto the view. Say if you use in path order. So this is taken from a secondary source. Rather than that, we'll directly take from the primary source. Yeah, so we'll take, say, this is segment. So you can sort this. Either we can keep this on top or this on top. So we can change the order, and then that apply that appears in the view according to the sort order that we specify there. Okay, right. So we'll actually do an exercise to plot the visualization that you are seeing on the view now. So this is point to point mapping. So this activity is called as point to point mapping. So the objective here is to create a view that shows a traveled path. So this is about a traveled path. Okay, and includes details to clarify the view. Okay, so if you hover over that, so it includes a lot of details to clarify the view. Okay, so it is the trip id is f, so visiting Europe, and the city is London. So you have the latitude and longitude, and also the trip cost and the path order. Okay, so the objective is to create this. So in this mapping workbook, so we'll use uh, mapping and also travel log. So we'll be using travel log and travel log and um, location mapping. So we'll be using two uh, data sources. Okay, so uh, we'll be working with disaggregated data to create the view for longitude in columns and latitude in columns. So um, we'll keep travel log uh, dot trip id in details. So we will, whatever we want in the uh, tooltip will be showing that in details, so that we'll be able to see that in the view. So trip id would be shown in details, so we can see the trip id in the tooltip like this. Okay, so we'll be using path order to path. So trip cost to size, trip cost to size, and also visiting to color, visiting to color. Okay, so city, and also we'll keeping city to label like this. Okay, so and we'll change that to attribute. So by doing this, we can create a view like this. So we'll actually perform this by doing detailed steps. Okay, so we'll create a new connection first to trip path mapping, trip path mapping dot xls. So how can we connect to a data source? We have to uh, click on this icon here, and then click on this icon, which is new data source. We'll be able to either select a file or a server. Okay, so because you are using Excel, so you choose Excel and specify the path that you want to give. So this is the data. So you can give trip path mapping, trip path mapping. So this will connect you to the um, connect you to the view, connect you to the data sources. Okay, so here we have multiple tables. So we have to create actually joins here. So we have to click add table. We have to first choose the tables, travel log. Okay, and also mapping and travel log. Okay, so the join clause should be mapping travel log, and both should be inner join. Okay, both should be inner join. The common field should be city between both. Common field should be city between both. Similarly, so we'll add um, another table again, um, which is a trip cost. Okay, so trip cost will be connected to travel log. So the relationship here is travel log and trip cost. Uh, okay, so here also we'll be using a common field. However, here the common field would be trip ID. The common field here would be trip ID, and also we'll be using an inner join. So that means only common fields between these two tables will be appearing in the view. Okay, so these two tables in the first place, and then these two tables in the first place. So common tables between travel log and trip cost, and mapping and travel log. So the common tables would common columns would be appearing in the resultant data set. Now we'll this is the first step of creating the uh, joins. So we have created a model here using joins. Now we'll create a view, right? So first of all, what we have to do is, so if there are any aggregations, we should not be using. So we'll go to an analysis and click on uncheck this aggregate measures. So we'll be using disaggregated values. Okay, so we'll be using longitude to columns, and then latitude to rows. Right. So we'll choose the map and we'll choose Tableau here. Okay. Now, so we'll define some fields and then place them into different marks cards. So we'll choose travel log and keep it in detail. Travel log dot trip ID. So in travel log, trip ID should will take this and then um, show this in detail to have that in the tooltip. Okay, we now have tooltip. Okay, now so we'll change the mark type to line. So now we'll change the mark type to line. Okay, then we'll drag the path order to path now. So where is the path order? In under measures, right? Okay, so we'll drag the path order and then place it under path. We'll drag the path order and place it in path. Right, from measures we'll drag trip cost to size. So trip cost we'll keep it in size. So this will increase the size of the line like this. So we'll drag visiting to color to know the visiting city. So for each visit the path will change. So we'll drag city to label. Okay. And then right click on the city field and change it to attribute. So we have to change that to attribute, or else it will have duplicate values. We have to change that to attribute. Right. Actually, so this label addition may result in multiple labels for the same city. So we got that multiple labels. See, I got multiple labels for the same city. Uh, See, for Hong Kong there are multiple labels, right? For Singapore there are multiple labels. Even for this, there are multiple labels. Okay. Um, if we get these multiple labels for the same city, if this occurs, um, click on the point and then choose mark labels and shows and show, choose never show. Okay, choose never show. So we should only remove the one mark. So we should first select the one mark that you want to delete. So if we first have to zoom in to the level wherein you want to see which is a duplicate. So because Hong Kong is a city and both a country, so you are getting that in a single view. Same is the case with Singapore, so we can ignore such cases. But however, if we get a um, if we get multiple city names, in some cases you'll be getting that. So in that cases, you can right click on the view, go to mark labels, and then click on show never. So one of the duplicates will be deleted, not shown in the view like that. So this is how. Uh, so okay, so I'm undoing this. Some issue, it got stuck. Um, I'm closing this and then I'll be reopening this again. So basically, you will get a point-to-point map like this by uh, by doing the same procedure that I've just explained. So by dropping the relevant fields into the marks cards, visiting, trip cost, city, and trip ID. So by hovering over the tooltip, you will be able to see the details like this. Okay, so that is about point-to-point mapping. So however, we also have the last topic in um, geographic analysis, which is using background images for spatial analysis. Okay, so we can use background images to display underneath your data in order to add more context to the marks in the view. For example, if you have some data, um, in the background you can add any images, something like what you are seeing, and then plot a data on top of that date on top of that image. Okay, a common use of background image is adding custom map images that correspond to a coordinate system in your data. Okay, so if there is a coordinate system of the in your data, and you can add a image which is corresponding to the same coordinate system of your which corresponds to the same coordinate system in your data. For example, you may have data that correspond to a human body like this. um, it will have same coordinates um, at each part. Okay. um, uh, However, that what I mean to say is, so if you divide the part divide the sheet, so it will have consistent coordinates. That is one example. So if we can take another example where you may have data that correspond to several floors in a building. So you can use background images to overlay that data on an actual floor plan of the building to give more context. So the floor plan never changes, right? So the data points of different floors in the building can be plotted against the floor plan of a building, and by giving that, so you can give a more context to the visualization. So other examples of using background imaging maybe showing a model of the sea floor. So a model of the sea floor can also be shown in the background image, um, and also the images of some web pages for analyzing web logs. That is also one of the examples. So, or even levels from video games to visualize player statistics can also be used, okay, as a background image. Okay. However, there is a limitation to it. Since the picture is static in nature, so you'll only be able to zoom as your picture quality allows for. Okay. So if your picture quality is good, so you can zoom in to the most possible zoom level. Okay. If your picture quality is not nice, you will not be able to do that. So this is the only limitation here, right? So you can also use the background images as a map also. Okay. So um, as you are using the background image as a static picture, so you can use a background image of a map as well, of a map as well. Okay. So we'll go to map layers. Okay. And you have different types of map layers. Okay. This is the sea surface temperature. So you can also use such background images for plotting your graph as well. So this is a snow cover data. So if your data is related to such type of a uh, such type of a s- data related to snow or ice cover on the planet, so you can use such background images. Okay. Yeah. And now, so we'll actually try to plot a image like plotted data like this on a image. Okay. So before going forward, so we'll see what the spatial analysis is all about. So you can use Tableau's mapping capabilities to track the position of data that is not geographical in nature. So here this data is not geographical in nature, right? So however, Tableau's you can use the Tableau's mapping capabilities to track the position of the data. For example, this data is related to the stomach part or lower back part. This is a back area, right? So uh, it uh, using Tableau's mapping capabilities, you will be able to exactly plot the data on on top of the region, lower back region. And if you see this, so it's a shoulder data. So it's an injury on located on a shoulder. So this is a front view. Okay, so you are able to plot the data exactly on that position. So you can do that using Tableau's mapping capabilities. Okay, typically there are different scenarios which may have data structured in this way already with x and y coordinates. Okay, so most of the cases you will be having data structured in coordinate system in x and y for plotting these graphs, or there there is no logical coordinate data at all. So there, in some cases, there will be no logical coordinate data at all. So however, the best practice when mapping is using a table for position values. Okay, so position value says x comma y, so these are the coordinates. So we have to use this table for position values as x and y for coordinates, and we have to join or blend to data based on the position ID dimension field. So we'll have a position ID dimension field, and we have to blend that to the x and y coordinates. Okay, so we'll see how we can do that using this example. So this is the activity of a background image. So we'll the objective here is to use geospatial analysis to show points as they relate to each other. Okay, so the objective is to use geospatial analysis to show points as they relate to each other. Right. I will tell you the directions, and we'll go and perform the detailed steps again. Okay, so first we'll take a new worksheet and then we'll connect to work injury data. So this is a work injury data. So the data will look like this. It will have injury date, location of the injury. Okay, this is the part, body part. This is the injury date. You have mechanism of injury, nature of injury, and you have location code. Okay, you have location code in measure, and we have age, location code again, uh, location x coordinate, location y coordinate. Okay, so these are the fields that you have in the data source. So you can directly see that in the Excel as well. Okay, we have two tables here. So in injury location, we have location code. Along with that, we have x coordinate and y coordinate. So in this data, we have the coordinates readily available. So in injuries table, we have mechanism, age, injury date, nature of injury, mechanism of injury, location of injury, and location code. So location code is common between these two tables. Okay, right. So we'll see how we can plot using uh, these two tables in work injury data source. Right. So first we need to connect to the work injury data.xls file and include both sheets, injuries and injury location, by joining them by location code. So location code is a common field. So we have to join by location code. Okay, so we'll use the map menu. We'll use the map menu uh, and define a background image tied to the sorry. So work injury data source. So we will use the image called body map.gif. So this image is also provided. Okay, this is the image corresponding to the data that we have. Okay, so we have to use that image, and then we have to define the X field with the range 0 to 99. So now our aim is to create the coordinates for X axis, X and Y coordinates. So for that we have to define the field X with the ranges from 0 to 9, and we have to create Y field with the range 0 to 100. Okay, 0 to 99 and 0 to 100. So um, so the location X we have to we have to create first X and Y, and then we have to drag location X into columns and Y into rows like this. So we have to change the aggregation for both to average from sum. So we have to keep location of injury into details to have that in the tooltip like this, location of injury. Okay. Well, we can also use some size by number of records. So we can use number of records into size to know the um, number of injuries. So we can change that in the formatting in tooltip later. So we'll actually perform this task by performing detailed steps. So we'll open a new workbook here. We'll define the connection to injuries table using multiple tables first. So we'll first establish a connection. Work injury data. Right. So we have two tables, injuries and injury location here. Um, right. So now we have to add a location table. So we'll create a left join between injuries dot location code and injuries location. So we'll create a left join between injuries dot location code, okay, and also an injuries location code in injury location. Okay, so the common field is location code. So we'll take only injuries data. That's why we'll be using only left join. So the cardinality relationship here is many to one. So when we are deciding which cardinality we have to use, we have to think in cardinality level. So the location. Uh, so if you can answer me, uh, what will be the relationship between injuries and location? So location would be unique, right? But injuries would be multiple. So
Many to one.
it is a many to one relationship. That's why we have to take a left join like this. Okay, right. So okay, so now we'll go back. So we now that we have established a join here between two tables. So we'll go to the sheet. Yeah, this is the data. Now it is 5 work injury data. Okay, 5 work injury data. Right. Now we'll go to the map menu, then choose background images. Okay. From this link, um, so we'll choose injury plus work injury data. This will relate to the image to the correct data set. So from the background image dialog box that we get here like this, so we have to click on add image to add the background image. So we have to note that these settings define the background image to use. So the data it's tied to and the scale to be used when placing marks to the image. Okay, so we have to be careful here. Okay, while defining this, so this will be, the settings will define the background image to use. So we have to first browse the background image. So where is the background image? So it's in the data folder. Okay, this is the background image. Okay, so it is shown in the option view here in add background image dialog box, right? First we have chosen the background image. Now it will also take the data that is related, so it's associated with the data with the related image. Also um, it will also take into account the scale to be used. So, okay, so here we have to um, name. Okay, we have to name it. We'll name as injury image. Okay, so we have to choose by browsing and selecting the body map.gif. Okay, in X field you have to choose location, and left will you have to take 0, and this is a these are the coordinate values for x-axis. Okay, similarly for y field we have to take location as location y and 0 to 100. So this is to just adjust the view onto the data, so data onto the view. Okay, so right, we'll click on apply and okay. Okay, now so we'll use location x2 columns, and then right click and change the aggregation function to average. So the default is sum, so we'll change it to average. Now, so location y2 rows, and then change the aggregation to average. Okay, right. So we have started to get the image with one data point here. Now, so we'll drag drop location of injury to detail. Okay, now we almost got the complete picture. Okay, so we'll also use number of records to size. Okay, so here we can change by doing some formatting. So we'll click on the null indicator here, so which is having some unidentified values at the bottom right, and choose to filter nulls. Okay, we'll filter data. Okay, right, we'll click on the average location x on columns and click off show header. Similarly, so we don't want to show this axis label, so we'll also do the same for y axis. Click on show header. Okay, right, so we have to click on shape and then change the mark to a cross. So rather than this, we want to show a cross, so choose a cross like this. So click on color and then make the cross appear as red. So click on size and make the marks a little larger. Right. Click on the tooltip now. So you have to remove the references to location X and location Y. Okay, and the change in number of records to number of injuries. So go to worksheet tooltip, or you can directly go to tooltip here. Okay, so we'll keep the location of injuries as it is. So we don't want to show x and y coordinates like this. So we'll remove them and change number of records to number of injuries. We'll preview it. Okay, abdomen number of is 1. So we'll check the data. So lower back, yeah, it is a lower back. This is a shoulder. Yeah, we are able to get the location and injuries correctly. So this is how we can uh, we can uh, plot a data on top of a background image. Okay. So is that clear, or any questions in this? Excuse me. Yeah, we'll take a quick break. We'll come back again, and we'll look at the next topic, which is called as level of details expressions. So which is a very important topic. Okay. See you in next 5 minutes. Right, guys. So now we're going to discuss the topic of level of detail. Okay. So first of all, we'll try to. Are you in, guys?
Yeah, I'm here.
Yeah.
Yeah,
Right.
Grant.
So yeah. So first of all, we'll try to understand what is a LOD expression, or a level of detail expression. Okay. So LODs are used to perform the aggregation at the required dimensionality level, apart from the visualization level. So if you want to create any aggregation on each dimensionality level, apart from the visualization level, so in visualization there will be one aggregation. So apart from that, if you want to have a sub dimensionality level aggregation, we'll be using LOD functions. So we'll look into examples, and if you are not clear, you will be able to know that concept clearly when we perform some examples. So LODs will be executed at the data source level. Okay, so always LODs will be executed at the data source level against the table calculations, totals. So these where are table calculations executed? So they are executed at the Tableau level or visualization level. Totals, references will be all executed at the Tableau level, whereas LODs will be executed at the directly at the data source level itself. So um, because they are directly executed at the data source level, so there are advantages of it. So there are advantages of LODs. So we can create LODs in a calculated field like this. So we will see how we can do that. Okay, so at data source level execution, so it will improve the performance for the large data sources, because LODs are executed at the data source level. So it will improve the performance, because it will reduce the amount of data to be transferred over the network to the Tableau. Okay, so we are actually aggregating on any other dimensionality level apart from the visualization level, on a um, on a data source level also, using LOD expressions. So by doing so, what we are doing is we are reducing the amount of data that we are taking into the system. So for Tableau to query. So in turn, it will improve the performance of the queries also. Okay. So we'll first see the syntax. So first, there will be a LOD keyword. The first part is a LOD keyword. So the LOD keyword is fixed, or include, or exclude. So this is the first part. So what are these called? These are called LOD keywords. These are called LOD keywords, fixed, include or exclude. Okay. So the second part is dimensionality level. Okay. So these are LOD keywords, right? LOD keywords. This is the part one. And the second part is, so this is, I'm talking about the syntax. This is the first part. The second part is dimensionality level. The second part of the syntax is dimensionality level. Dimensionality level. And the third part is required aggregation. The third part is required aggregation. So we'll comment this. Okay, so this is the syntax. The first part is LOD keywords, either fixed, include or exclude. The second part is dimensionality level. The third part is required aggregation. Okay, so we have to note here that part 1 is independent of part 2. That is, the LOD keyword is independent of the dimensionality level. Okay, and part 2 is dependent on the part 1. So however, the dimensionality level on which you are aggregating is actually dependent on the uh, keyword, LOD keyword, because this is the keyword which defines what is the what is that you have to do the aggregation on. So is it a fixed, or you have to include that, or you have to exclude that. So part 2 is always dependent on part 1. However, part 1 is not dependent on part 2. Okay, so part 3, this part 3 required aggregation um, contains normal aggregates or formula or conditions. Okay, so normal aggregates like sum or average. Okay, so it contains that aggregations, normal aggregations. So from Tableau 10 it is possible to take dimensionality expression directly in the LOD formula. So that was not there before, so you can take the dimensionality expression directly in the formula. Okay, so that is not an issue from now. Okay, earlier up to 9 only column names are permitted. Okay, LODs are newly added in the Tableau 9 version, and from 10 version you will be able to add the dimensionality expression directly in the LOD function also. So first we'll look at the fixed LOD. We'll look at the fixed LOD for keyword. So for example, if you have, okay, the syntax is like this. Right. So we have to write this function in square brackets. So the first keyword is fixed here, and then it's customer ID. So dimensionality level, we will take customer ID, for example. Okay. Then colon. The aggregation is sum. You will take sum of sales. Okay. So here we are taking fixed in the of LOD keyword. Dimensionality level is customer ID, and aggregation, required aggregation is sum of sales. Okay, so this is the uh, this is the syntax. So however, um, okay, if you have state and county as two dimensions, okay, if you have state and county as two dimensions, so we'll first do an exercise to understand this better. First, we'll perform a task um, to understand this better. Okay, so we'll in this task we'll display department wise and category wise total sales, and also display department sales, and also display grand total of sales. So what it means is we'll be displaying grand and subtotal of every row in is the concept. Okay, so for that we'll drag department and category into rows, and then sales into label of the marks. You can also call it as text in the marks card. Okay, so now will create a calculated field with the name department sales, and then we'll create a LOD function, LOD expression. Department sales is the calculated field name, and the formula here is fixed of department sum of sales. We'll extract this first. So LODs work on only extracts. So we'll keep this as department sales. Okay, so it is a duplicate. Okay, now the calculation is valid. So we'll name it as 2. We'll delete this. Right. So here we have a department sales as calculated field, which is a fixed LOD expression. So we'll drag department sales and drop it into the visualization to perform blended access. So now we'll create a field with the name grand total sales with the formula. So this is grand total sales. Here we will write the formula as sum of sales. So within brackets, now we'll drop the field into the visualization. So we have, see, we have department sales. So which is an aggregation. We have actual sales for each category, and this is a grand total sales. So using LOD functions, what we have done is, um, here we want an aggregation at a department level. Okay, so for furniture, we are able to show furniture data like this in one row, in one column, and sales for each category like this in each row. Okay, so and also we were able to show the grand totals on a column level for each row, same values. Here for each row in this in furniture, for all furniture rows, we are able to show the same department sales values. For aggregating on a dimensionality level like this, we are using LOD functions. So is that clear now?
Yeah, Kranti. So this is nothing but in the in dimensions concept, type 6 or type 7, most recent information or something, right? If you see most recent information, that will be repeated for all the records.
Mm, okay, so rather than saying it as most recent information, so
Uh-huh.
you can say that the dimension on which you want to see the aggregation on.
Okay.
Okay, so that can be any dimension. So you can even use a customer ID for that. So you can use any dimension and then um, and then show the aggregation on that level like that. So basically, level of detail function expressions are used for this purpose.
So,
Okay,
and this will
so
work for only for extracted
yeah,
content only.
yeah,
Okay.
extracted content only. Okay, right. So similarly, if we use include and exclude, so it will include will actually include only that content, and exclude will actually exclude the content that we use in the expression. Okay, so basically we can use the same formula but use the include and exclude for including or excluding the value. Okay, so that's about the level of details. Here we have few more exercises to do, like building a visualization and building a dashboard in the first place. Okay, so right, so uh, in Tableau, we can build worksheets and then combine different worksheets and make it into a dashboard like this. Okay, so basically, so first we have to build. First, we have to build a worksheet like this. So how do you build this worksheet? So you first use this latitude and longitude from the measures data, and then plot it on the columns and rows. So you'll be able to get a view, and then use in the marks card profit, sales, state, and postal code. So you'll be able to view a data like this, and in filters, drag drop year. Okay, so which is a order date aggregation of year. So you'll be able to get a year filter like this. So similarly, you can build multiple or three other two other worksheets like this. So this is a cross tab of sales and profits. Okay, sales in x-axis, profit in y-axis. Okay, so we are showing um, multiple dimensions by different marks. So region is shown um, in shape. So you're able to see that different regions are shown in different. So if you see plus, that means it's a southern region. So if you see cross, that is a western region. So if you see a square, then it is a east region. So similarly, if you see a circle, that's a central region. Okay, so region is shown as a shape here. So department in color. So all the office supplies departments are shown in orange, furniture in blue, and technology in gray. Okay, so customer names are anyways shown in text. So in tooltips we have category also. So categories, binders, and binder accessories. So here we are able to get that by drag dropping the detail into the category. Okay, category into detail marks. So we have built the worksheet like that. Also, this is a text table. It's also called as a cross tab or a simple text table. So we're just using order ID, customer name, and the order date. Okay, so in measures we have used sales and also profits, and we are actually using this order date, okay, for multiple worksheets. Okay, so for selected worksheets we are using, so which is sales by location and plot of sales and profits. For these two worksheets we are using this order date filter. Okay, so once that those three uh, uh, worksheets are developed, so you can click on this dashboard, and then you can drag drop these worksheets onto the view like this. So you can drag next to the other dashboards, other worksheets, so you'll get a view like this. Okay, so wherein if you select the filter, so that will affect the multiple views in the dashboard, multiple views in the dashboard. Okay, like this. Okay, so there are some useful tips also, like you can show the dashboard title here, and also you can make this filter as floating. So if you make it as a floating object, so you can drag drop and place the filter uh, floating object anywhere in the view. You can make use of the space. Okay, similarly, you can make the worksheets like this, and also filter out the data based on the filtered sheet like this. Okay, so this is an action where you can click on that arrow mark and then go back to the summary dashboard like this. Okay, so this is a one type of an action called as a return to the summary dashboard. So it's a one type of an action. So using actions we can make this possible. So because we have touched upon action, so we'll see what are different types of actions available in Tableau. So there are three types of actions available in Tableau. So one is highlight action, the other one is filter action, and the third one is URL action. So filter action, highlight action, and URL action. So if you want to make any actions, so there are three options for it. Okay, what does a highlight action do? So if you highlight actions allows you to call attention to marks of interest by coloring select marks and dimming all others. Okay, so for example, okay, if you are using this highlight action, so this is the result. Okay, so when you select hover over furniture, are you able to see only furniture data in monthly retail sales trend here? That is called as a highlight action. So when you hover over office supplies, you are able to see only office supplies trend line here at the bottom. Similarly, if you hover over technology in retail profit ratio KPI, you'll be able to see only technology trend line in monthly retail sales. Okay, so that is possible by doing a highlight action. Okay, So highlight actions allows you to call attention to marks of interest by coloring select marks and dimming all others like this. Okay, you can highlight marks in the view by selecting the marks you want to highlight. So you can do that by selecting the marks in one view. Right. So there is also other kind of an action called filter action. So filter actions are a way to send information between worksheets. So typically a filter action is used to send information from a selected mark to another sheet showing related information. So for example, so this is a filter action. Okay, so if you click on this filter action, what is happening is it is taking you to uh, another sheet. It is taking you to another sheet like this. Okay, so a filter action or a way to send information between worksheets. Typically, a filter action is used to send information from a selected mark, to the another sheet showing related information. So for example, when you're looking at a view showing sales prices of house, you may want to be able to select a particular house and show all comparable houses in different views. So filter actions work by sending the data values of relevant source fields as filters to the destination sheet. So there is a uh, source icon and also a destination field. So by clicking on that using filter actions, you'll be going to the destination sheet like this. Okay. So the third type of URL action is URL action. Third type of action is URL action. So that means a URL action is a hyperlink that points to a web page or file or a web-based resource outside of Tableau. So you can use URL actions to link to more information about your data that may be hosted outside your data source. Okay, if you don't have any data and if, inside the data source, if you want to show data outside the data source, uh, you can make the relevant link to your data. So you can substitute the field values of a selection into a URL as parameters also. So for example, this is a URL action. So when you click on that, so it is taking you to Tableau website. So using URL action, you can uh, you can go to a different websites like that. Okay, so um, how do you do that? So we'll perform a task to add actions. Okay, so the objective here is to add interactivity to the dashboard and help focus the user to specific area of interest. Okay, be it highlighting or navigating to another page, or navigating to a different data altogether. Okay, so here, so we will modify the, okay, here um, the directions, I'll tell you the directions first and then I'll take you to the detailed steps. So in this particular sheet, so first we have to make sure that the quick filter drop down menu to affect only the worksheets on the dashboard. So we have to check what is this quick filter affecting on. So here we have to see what are the sheets. So sales by location, plot of sales by location, and transaction details. So these are only transactions, sales by profit and profits. And so these are the only three worksheets in the dashboard. So the filter is fine. So we have to check that. Okay. Now you have to use the dashboard action to allow the user to click on the map and filter the scatter plot. So you have to allow the user to click on the map and it have to filter the scatter plot like this. Okay, so you are able to notice the difference. So you have to filter on the map and it should change the scatter plot, right? And you have to use select to run the action, and show all the values when clearing the selection. Okay, so we have to select to show to run the action, and we have to show all values when clearing the selection. Okay, right. So this is the requirement. So we have to create another filter action to allow a user to click on the scatter plot and filter the transaction details. So if you click on the scatter plot, it should also only show the relevant transaction details. Okay, that's also a filter action. Okay, so we have to use select to run the action and show all values when clearing the selection. Okay, so this is show all values to clearing the selection. So we have to select to show only the relevant values, right? So that is the one more requirement. So we have to create a menu driven action to allow a user to look up to a web based map of a postal code when they select one from the map. So for that you have to use a URL action. So obtain the URL for the zip code lookup for your favorite search engine, and then use the variable postcode for the lookup. So we'll see how we can do that. So Google Maps lookup can be used to do that. So these are the directions that you have to follow. So we'll do the detailed steps. So we'll go into the worksheet view, and here, so we already checked the uh, check the content where on which this worksheets on which the filter is applying. So this is the important thing that we have to check: transaction details, plot of sales and profits, and sales by location. These are the three worksheet on which this filter is applying. Okay, uh, so we have to click on the drop down menu from the year click filter, and then select apply to worksheet selected worksheets. Okay, so on the drop down menu, so we have to go to apply to worksheets and selected worksheets, and um, we have to select the relevant worksheets. In the dialog box that opens, click on the button for all on dashboard, or you can select whichever you want to apply the filter on. Okay, right. So now you can close this, and then you can check this filter. So by doing so, it should affect the all the three uh, worksheets. So is it affecting? Yes, it is affecting. So then the filter is working fine, right? So now we'll use dashboard actions to allow a user to click on the map and filter the scatter plot. So from dashboard, we'll click on action, and um, these are the different actions that we have. So if in the first place this will not be there, so we need to click on add action, and you have to choose three types of actions here: either filter, highlight, or URL. So what does highlight do? It will highlight only the relevant data if you create a highlight action. So if you choose a filter data, it will filter. So in the case where you have selected one of the customers in scatter plot, you are able to see only four rows. So that means your filter action was used here. Similarly, we can use a URL action as well. Okay, so we'll select filter action first, and then here in the dialog box we have to name it as map to scatter. So I've already made that, so I'll open that, map to scatter. Okay, I'll edit this so to show this. Okay, here I've named it as map to scatter, and then the source sheet should be this sales by location. Okay, so because the filter should be sales by location, so for year of order. So the filter should be sales by location in summary dashboard. Okay, and the target sheet should be on plot of sales and profits. So the target should be plot of sales, this one, and profits, this one. Okay, we have to make sure that these are selected. Okay, here transaction details also are selected, right? So we use select to run the action. So select means if you select only, that action runs. So for that you have to use select here. So we'll choose show all values for clearing the selection option. Okay, show all values for clearing the selection option. So if you click on all, so the selection action will be cleared. So for that you have to click on show all action here. So we'll test the filter action by clicking on the scatter plot to see if the controls are okay or not. So by using that filter action, so this filter is applied on both the scatter plot and a text graph like this. Okay, now we'll create a menu driven action to allow a user to look up for a web map of a postal code when they select one of the map. So from dashboard, again we'll go to action and click on add action, and we'll create a action called as lookup code. Okay, so from here, so what we'll do is um, we'll use menu here. So we'll use run action on menu. We'll name this as lookup zip code. So we'll define the URL to look up for the location in your favorite search engine and use the arrow to the right of the URL box like this. Okay, and then URL text box to reference the variable postal code. So you can actually search for the postal code and then insert the postal code here. Okay, so Google Maps lookup will be shown here. Okay, so you can save this, and then once this is ready, so you can use that in the visualization. Okay, so this is and similarly you can also um use a highlight action. Okay, this is a filter action which is from scatter to details. So if you select a particular plot on sales and profits, so it will take you to transaction details only. Okay, right. So you will have a highlight action here. We'll go to dashboard actions. So we'll have a highlight department. So here in KPI dashboard, so the name of the dashboard is KPI dashboard here. So the name of the uh, sheet is monthly retail sales. This is which is this. Okay, if you hover on that, so the run action should be on hover here because we are using a highlight action. So that should take you to monthly retail sales. Monthly retail sales. So the selection field should be only department here. I'm clicking on OK here and OK. So by creating that action like that, by going to dashboard and clicking on action and clicking on add action, you can click on highlight action. So we have to name the action, click on hover. You have to select the dashboard from the drop down list like KPI dashboard, and then select only those uh, those sheets here, retail profit KPI ratio, only that sheet should be selected, rest all should be unchecked. And that is the source sheet, and the target sheet is monthly retail sales. So monthly retail sales should also only be selected here, and should be on selected fields, which is department, because we are only showing on department. And click on OK. So that will create a highlight action like this, highlight action like this. Okay. So this is about actions, how we can use actions in Tableau. Okay. So there are few other visualizations, advanced visualizations, which are predominantly used in Tableau. Okay, this is called as a Pareto chart. Okay, and this is a box and whisker plot. So we have discussed about this box and whisker plot in the types of chart in earlier class. So this is used when distribution of data has to be shown. Okay, if there is the multiple data points here, see there are multiple data points, and you can show maximum, minimum, median, and also the quartile ranges of the data, uh, and, and can subdivide by different dimensions also like this. So when you want to show such type of a data, so you will be using this data type, using this chart type. So I've also shared you a document where it clearly indicates which type of chart should be used on which type of data. Go through that, you'll be able to understand this. So the one more chart type of a chart that we predominantly use is a Pareto chart. So Pareto chart is nothing but a 80-20 principle chart. So designed by a scientist called Pareto. Um, so basically, uh, when we want to see how much percentage of customers are contributing to maximum profits, so we will be using such type of a Pareto chart. Here we are able to see here that almost uh, 19.71, almost 20% of the customers are responsible for 68.4% of the profits. So if your business concentrates on only these customers, so these customers, so the customer names are also shown here. So if the business concentrates on only these customers also, the profit, the business will be in profitable, rather than catering to all these customers. Okay, so using such a insightful graph, you can say to the business that you just concentrate more on these customers, or keep them as your loyal customers, because they are generating you the lion's share of profits. So give them some incentives, or do whatever to uh, keep them as your loyal customers, and make them as a repeat customers to generate value. So you can give that information, and as a descriptive information also, you can say them that as an insight, these 20% of the customers are responsible for almost 70% of your profits. So that's a very good insight that a business can take and take an action upon. Okay, so using a Pareto chart, you can do such type of an analysis, where you have just taken a profit and also customers, and then plotted this graph. Okay, so this is one of the useful graphs that you can make. I'll share these dashboards with you. Yeah, if you want to show top end also, you can show top end like this, and then um, you can create a rank. So we have done a few such examples in our previous classes also, where using index, we have created ranks. So rank is nothing but an index. So if you see that, so it is index, its formula is index. So uh, it's a calculated field created, and you have used that in the middle of region and item of sales, and you have sorted that in a descending order. Okay, so by doing so, what we have done is, so it's an ascending order, sorry. So by doing so, what we have done is, um, um, we so sorry, it is a descending order, but the rank would be from top to bottom. So it is from 1 to 10. So we have shown ranks like this. So when top N analysis is required, we can show such type of charts as well. Okay, so this is all about Tableau desktop that I wanted to discuss. From next week would be the last week of the classes, and we will be discussing about Tableau Server. So Tableau Server is for Tableau administrators. So if you want to venture into a role of a Tableau administrator, so you have to know about Tableau Server, so which we will discuss next week for the next 4 days, and we'll finish the course. So all the things that we have discussed till now is performed by a Tableau developer. So there are two roles whenever you apply for a Tableau role. So it's a developer or a administrator. So administrator will do all this developing and designing part. Developer will do all the designing and development part, and administrator will actually manage the dashboards. He will create groups, he will create sites, he will assign permissions, he will make sure the security of the dashboards is taken care of. You will also see the load balancing act. So we'll see all that aspects in next week. Okay, any questions till now?
Currently, like you said,
Uh,
next week, but looking at the schedule that, like, Anand sent a long tag, it showed like September 6th was the last class.
Sorry.
Like, remember Anand, when the Tableau class started,
Mm.
he sent a schedule saying every week from Monday to
Yeah, yeah.
Thursday. It said
Mm.
like September 6th was the last class.
Yes, obviously, yes. So it got extended to 1 week. I know that.
Oh, okay.
See, the thing is, most people doesn't include this Tableau admin part in it, or
Oh,
they'll
okay.
just cover the basics. But I don't want to do that. I want to cover more detailed. So even in the topics that we have discussed, we have discussed in more detail rather than discussing superficially. So that's why we've taken. So Anand keep on insisting me that, I mean, you have to do that within 13 days or 32 days. But the thing is, I want to say more, so I want to explain more. So that's why it will take a couple of more days extra. So 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 if you don't want to take the classes, it's up to you. So
No,
is that
I'll take it.
that okay?
Just like Monday, I don't think I'll be able to be on because remember I told you that tomorrow I'm actually flying to India. So
Oh,
I'll
you
reach
are
there on like,
Sid, right?
yeah.
Okay.
So yeah, I mean, I'll reach there like Monday morning. So that means on
Mm.
American time, I won't be able to be on just Monday.
Okay. Okay.
Yeah.
Yeah, you can go through the recording. So I'll be covering only the introductory part on Monday, anyways.
Okay.
Okay. Right. Okay then. So see you next week.
Yeah.
okay.
Okay. Bye
Thanks,
bye.
Kanti. Bye.